Alright, Unit 3, Learning Target 2b. I can evaluate a piecewise function at a specific value. Last learning target looked at just a regular function evaluating at a specific value, and here we're going to look at a piecewise function. This right here is an example of a piecewise equation. To the right of it is a piecewise graph. You'll notice that a piecewise equation is going to have several different pieces to it, which makes sense because it's called a piecewise function. This specific piecewise function says that the function equals 2 if the x value is less than or equal to 1. So if you look at the graph on the right, you'll see that you've got just that straight line at 2 for x values that are all less than 1. The next piece of this function says f of x equals 3x if x is less than or equal to 2 and greater than or equal to negative 1. So we've got this line, this y equals 3x line, and it's in between negative 1 and positive 2. Then the last piece of this, the piecewise function, says that f of x equals negative x plus 4 if x is greater than 2. That equal sign shouldn't be there, I'm sorry. So x is greater than 2, we want this equation right here. So we've got this line that represents negative x plus 4, and we have this line only for values of x that are greater than 2. We'll talk more about piecewise graphs in the next learning target. So right now all we're going to talk about is evaluating the function at a specific value, just like we did before. So h of x is the example that we're going to use, and you'll notice it has 3 pieces, just like the f of x equation that we have above it. The first example that we're going to do is going to ask you to find the value of h of negative 5. So using that piecewise function, we're going to fill in negative 5 for our x value, just like we did before, and then we will figure out what the value is. Okay, so h of negative 5. Which equation will we fill in is the first thing that you should ask yourself. If our x value is negative 5, 1, 2, or 3, which piece of that piecewise function does it fit into? So negative 5 we know is less than negative 3. Therefore we're going to use the first equation. So we would fill negative 5 in parentheses, squared, minus 1, using this first equation that's up top. Again, we're using that equation because your x value is less than negative 3. Negative 5 squared is 25, minus 1 is 24. So we would say h of negative 5 is 24. Another example might look something like find h of 0. So again, you'd ask yourself first, which of the 3 equations, 1, 2, or 3, does 0 fit into? Well, the first one says x is less than negative 3. Well, we know that 0 is not less than negative 3. The next equation, equation 2, says if x is in between negative 3 and 0. It also says less than or equal to 0. So since 0 equals 0, we would say h of 0, and we would use whatever equation goes with that second line. And in this one, there's not an x value to fill in. It just says equals 3. Therefore, that's just our answer. H of 0 equals 3. Do a couple more, and hopefully you'll start to catch on to the pattern of how this is working. So example 3. Find h of 1. So again, you ask yourself first, which of those 3 pieces does it fit into? Where does 1 fall in these first 3 equations? So we know that 1 is more than negative 3, so it's not going to be the first one. 1 is not in between negative 3 and 0, so it's not the second one. But the third one says x is greater than 0. Well, I think we'd all agree that 1 is greater than 0, so that means we're going to fill 1 in to that third equation. We'd say 2 and then in parentheses 1 plus 1. 2 times 1 is just 2, plus 1 is 3. So we could say h of 1 equals 3. Example 4. Find h of negative 3. Alright, h of negative 3. So ask yourself, which piece does that fit into? Negative 3 is not less than negative 3, so it's not that first one. But that second one says x is greater than or equal to negative 3. So since it's got that or equal to, we know we're going to use the second piece. Again, in this one, there's no x value to fill in, so it's just 3. That 3 that comes from the second equation. So we can say h of negative 3 is just 3. Alright, let's do the same thing, but let's use a different piecewise equation just to see how it might look differently. So in this specific piecewise function, there's only 2 pieces. We've got x plus 5 if x is less than 3, and negative 3x if x is greater than or equal to 3. So we'll do 3 examples with this one. The first example says find f of 0. So just like we did before, the first thing you need to ask yourself is, where does 0 fit in to these 2 pieces? So is 0 less than 3, or is 0 greater than or equal to 3? And we would know that 0 is less than 3. Therefore, we're going to use that top equation, and we're going to fill in 0 for your x value. So we would say 0 plus 5 is just 5. So f of 0 equals 5. Example 6. Find f of 6. So is 6 less than 3, or is 6 greater than or equal to 3? Since 6 is greater than or equal to 3, we know we're going to use that bottom equation. We'll take 6 and fill it in for our x value. So we would say f of 6 equals negative 3, and then in parentheses 6. So negative 3 times 6 is negative 18. Therefore, f of 6 equals negative 18. Alright, last example. Here we're going to find f of 3. So our two options are less than 3 or greater than or equal to 3. This f of 3 would fall into the second equation because it's got the equal sign. So again, we're going to take 3 and fill it in where x value used to be. So we would have negative 3 and then in parentheses 3. Negative 3 times 3 is negative 9. So f of 3 is negative 9. Alright, so that's all for the examples and for this video. But if you have any confusion, please feel free to ask people around you or ask myself before you leave class. And if you're watching this at home or outside of class, definitely ask if you have any questions when you get into class. Have a good day.